Hello everyone and welcome back to my YouTube channel. Today we are going to see State Board Class 10 Science 1 Chapter number 4. Name of the chapter is Effects of Electric Current. In this particular chapter we are going to learn about the energy transfer in electric circuit, heating effects of electric current and the magnetic effects of electric current. Under these three particular important topics, we are going to discuss different terms related to it and various phenomena of electric current and its effect we are going to learn. In a previous standards already we have studied about electric current and the terms related with it, like we had already said about the electric current which we measure in the ampere denoted by the capital letter I. Unit is ampere. We studied about the potential difference which we denote by a capital letter V and unit is volts. Then we studied about the resistance, we studied about the resistivity whose units are ohm and ohm meter respectively. These things already we have studied in a previous standards. Now in this particular topic we are going to talk about the effects of electric current, means which we have studied in a previous standard, that we are going to utilize in this particular chapter to understand the various effects of the electric current. Here they have given three different pictures, picture A, picture B and picture C. As you can see in this, the first picture, if I am talking about picture A, in this you can see the household electrical circuit they have given, where we have the lamp, we have the heater, we have the television, we have the side lamp, and they all are connected to the electrical circuit. Another picture they have shown that one electrical fan is working. Another picture they have shown with the power supply, that is the battery is used, electrical bell and the switch is there. Means the electrical circuit they have given, the different types of the electrical circuits they have given in this particular section. Now if I am talking about the effects of electric current and the various effects we have, before that we will talk about the energy transfer in an electrical circuit, how the energy get transfers from one place to the another place in the electrical circuit, or from one point to the another point in the electrical circuit. Electrical circuit in a previous standard already we have studied, it should be a closed circuit. If it is an open circuit, then it will not work. In this particular section they have given a one electrical circuit. You can see over here we have the power supply or the source of power. Then we have a resistance, that is a load in that particular circuit. Here we have a plug key, we have an ammeter to measure the current, we have a voltmeter to measure the potential difference across point A and point B, and the current I is flowing in the circuit. In this particular section we will talk about the energy transfer, how the energy is getting transferred, because when we talk about in this particular section, this battery is nothing but the source of energy which supplies the energy, and the positive terminal of this supplies that energy to the electrical circuit, and it returns back to the battery in a form of electrical current. Now here if I am talking about the electrical power, which we denote by the capital letter P, electrical power, which is nothing but the energy upon time required. How I will get the energy? Energy is nothing but the potential into the charge. Potential into charge, and time required is let's the time t. For the time t, potential difference AB or the VAB is maintained and the charge Q flows through it. And as we know that this Q upon T is nothing but the I. That is a definition of the electrical current, that is the charge per unit time. That is nothing but what the electrical current. So here I can substitute this value into here in this particular section, and we will receive V into I. So power into time, if we will multiply it with the time, we will get the heat produced in that particular section. Because when we talk about the electrical energy or the electrical current, if it flows in a conductor continuously, then it produces a heat, and that heat we can find out with the help of a power into time, electrical power into time, for which that particular current is flowing in the circuit. So VIT, H is equal to P into T, or that P we can write as a V into I. This P, if I'm talking about P, I can write as a V into I. From here we are getting, and the time as it is. So according to Ohm's law, I into R is equal to VAB. So we can substitute this value over here, and we will be getting a V square into T upon R. We can replace in that particular section. So different forms we can write. Similarly, we can write H is equal to I square RT. So these are the different formats in which we can write the value of H. Okay, so we can go ahead. Unit of electrical power, when we talk about unit of electrical power, as we know the formula, V into I is electrical power. Unit for the potential difference is a volt. Unit for the current is a ampere. So volt into ampere. We can again reform it. Volt is nothing but the joule per coulomb, and ampere is nothing but the coulomb per second. So here coulomb will get cancelled and the joule per second, which we call it as a watt. Thus the unit of electrical power is watt. Next section, that is the heating effect of electric current. When we talk about this heating effect of electrical current, whenever electric current flows in a conductor, and conductor is having a certain resistance, because getting a zero resistance is not possible. We can minimize it in a different materials like gold and a silver. They have at least resistances. That's why they are the best conductors. So we can have a less value, but each and every material is having certain resistance, and when the electrical current flows through it, they are producing a resistance to the electricity. So in that particular case, when there is a resistance in the particular conductor, that utilizes the electrical energy. It consumes a certain sort of electrical energy, and that consumed electrical energy gets converted into the heat. When a resistor, you can see over here, they have mentioned also, when a resistor is connected in an electrical circuit, heat is produced in it due to the current. This is known as the heating effect of electric current. So that heat which is getting produced in the electrical conductor, because of that, this particular phenomena is called as the heating effect of electric current. Now further, if we will go for that, we have a different kind of the electrical instrument or the devices or the appliances where we are using this particular phenomena of the electric current. Coiled coil, or the solenoid type coil, different kind of coils we have. Nichrome is used in electric heater, cooker as a resistor. And this particular wires which we are using, or the materials which we are using, they have a high resistance and high melting point. Due to that, what happened, they start to get heat up when the electricity is passed through this particular material conductors. They get heated, and the temperature goes up to 3400 degrees Celsius. And this, when they start to get heat, they produce light also. They start to emit the light also. So here you can see the pictures of the different appliances, like the coil of cooker, coil of heater. The color changes. They start to emit the light also when they get heat up. Even in a bulbs, electrical bulbs, we are using the nichrome wire, and this the nichrome wire we have. Another thing on the other side, when we talk about the unit of the electrical power. As already we have stated that watt is nothing but the unit of electrical power, but this is a very small unit we have. The commercial unit which we are using at home, we talk about in 1,000 watt, or the 1 kilowatt is unit as a unit to measure electrical power. At home, you might have seen your electricity bill, that number of units consumed in a month. So that number of units consumed means that many kilowatt is unit is consumed, or electric power is consumed. In the practice, 1 kilowatt is used for 1 hour. It will mean 1 kilowatt hour of electrical energy is used. So here you can see 1 kWh. So 1000 watt into 3600 seconds means actually we consumed 3.6 into 10 raised to 6 joules. This 3600 we are getting from the 1 hour. 1 hour contains, or 1 hour is consist of a 3600 seconds. So this is about the commercial unit. Uses of coil they have given. Then afterward, the next they have given a different instruments over here. These are the different kind of fuses we have. Now the use of this fuse is what, or the MCB what we are using, what actually they are. This is a digital circuit breaker we have, MCB. Miniature circuit breaker we are calling it. The name they have mentioned over here, miniature circuit breaker, MCB switches. And these are the different kind of fuses which we are using in an electrical circuit. Now the use of fuse is what? The heating effect of electric current, the phenomena we are using in the fuse. When we are using a number of appliances simultaneously in a home, the higher appliances like air conditioner, refrigerators, then the coolers, geysers, all the heavy appliances if we are using all together, then the electric current what the conductor is drawing, or whatever is flowing in an electrical conductor, is too high. And due to that, what happened? As we have studied a formula for the heating effect, we studied what H is equal to I square RT. So you can see here the relation between H and I. Square of current means 2 ampere. If the current is increasing, then what will happen? Heat will increase 4 times, because square of current we have. So as more and more current is drawn, more heat will get produced in the electrical conductors, the electrical wires what we are having at home. So that more heating, if it is there, then there is a chances that the coating, the rubber coating or the plastic coating what we have on the conductors, it will melt. And once it's melting, it will get in a contact with the other wire, because we have a 3 wires in an electrical circuit. We have a 3 wires in the electrical circuit. We have 3 wires: line, neutral and earth. So chances are there this wire will come in a contact, and then there will be a short circuit. There will be a short circuit. So in the short circuit, what will happen? It may lead towards the fire, means a disaster. So to avoid this kind of a situation, what we are doing, we are using a different kind of fuses. This different kind of fuses we are using. The wire which is used in the fuse is having a low melting point than the conductor. So what happened? When the more electric current is passing through it, this wire melts before the loss in the conducting wires or the electrical wires. So due to that, what happens? Circuit breaks. You can see here the circuit break. Once the circuit break means what? Drawing of current will stop and the electrical short circuit can be avoided. So use of this fuses are to avoid the electrical short circuit. In same way, we have a digital MCBs. These are the digital MCBs, miniature circuit breaker. When more current is drawn from the electrical conductor, means more than their limit, then the circuit breaks automatically, and this avoids the loss of due to the electrical short circuit. So these are the things we have related with the heating effect of electric current. In the next lecture, we will go towards the magnetic effect of electric current.